Hello students, I hope you all are fine. Students, as you know that yesterday we were discussing about the hybridization. We have covered SP, SP2, SP3. So today we will cover the remaining hybridization. Okay students? Yes. SP3 dehybridization. Students, what is the SP3 dehybridization? In SP3D, SP3 hybridization, what will happen students? 1s 3p, okay, and one d orbital, they take part, they get overlapping, they overlap, and they form the hybrid orbitals. They form the 5 hybrid orbitals. How many? 5 hybrid orbitals. Okay, I hope this concept is clear to you. They form 5 hybrid orbital. Students, like that, if we take an example of PCl5, you know very well, phosphorus, atomic number is 15. Atomic number is 15. So students, configuration will be 2, 8, 5. Okay, so here valence electrons, or we can write in this way. In shells configuration, we will write subcell 1s2, 2s2, 2p6, 3s2, 3p3, 3p3. Okay, this one is the configuration for this one. Then students, up to this, it has noble gas configuration, it has neon configuration. It has neon configuration. So after that, these are the valence electron. These five are the valence electron here. Okay, students. So we can write ground state for phosphorus. Ground state for phosphorus. So students, phosphorus ground state is 3s, 3p, and 3d. So 3s, 3p, 3d. You know very well, in p there are 3 orbitals. In d there are 5. Students, in ground state there are 2 electron in 3s and 3 electrons are in 3p. Okay, but students, after absorbing some amount of energy, it can excite. Now write configuration for excited state. Then what will happen, students? Then what will happen? This one electron from here, it can excited, and it can move to 3D. It can excite it and it can move to 3D, next energy level. Okay, students. Then you can see now how many unpaired electrons we are having. Here this one, 1, 2, 3, 4, 5. So these 5s are the hybrid orbital here. These 5 are the hybrid orbitals. Okay. Then students, this one is, so we will give 1 Cl to this one this one, and 1 this one. So finally, student, you can see here 1s and 1, 2, 3, 3p and 1d. They are overlapping. They are involving in hybridization. So here hybridization will be sp3d, sp3d. Hybridization will be the sp3d. So in this way students we can calculate. In this way we can calculate. Then students, you can see the structure. You can see here 1s and p and 1 d orbitals. They are overlapping. They are overlapping, and after overlapping, they are giving this type of the geometry. And this one is the trigonal bipyramidal. Trigonal bipyramidal. Here angles will be this one. This one is the 90-degree angle, 90 degree, and this one is 120 degree, 120 degree. So here angles will be 90 degree and 120 degree, and geometry is known as the trigonal bipyramidal. Okay students, I hope this is clear to you. I hope this one is clear to you. Then let's see the next one. Next one is the sp3d2 hybridization. sp3d2 hybridization, students, like sp3d2. For example students, we can take sf6. We can take sf6. Here first of all you will identify the central element. Here central element is sulfur. You know very well atomic number for sulfur is 16. Now write down the electronic configuration. Further I am telling, then write down the electronic configuration. 1s2, 2s2, 2p6, 3s2, and 3p4. Okay students, so make the ground state for this one. Make the ground state and then excited state. You know very well, till here. It is configuration of neon, noble gas. So now these are the valence electrons. 6 valence electrons are there. So according to that you will make chart. Okay students. Yes. Okay students, so now you can make here in 3s, this one is 3s, this one is 3p, and this one is 3d. This one is the 3d. Okay, then you can fill the electrons. In 3s, in ground state there are 2 electrons, and in 3p there are 4 electrons. So first of all, according to Hund's rule, you will 2. You will fill singly, after that start pairing, after that start pairing. But student, in excited state, by absorbing some amount of energy, they can move to the higher energy level. Why? Because here d orbital is vacant. Here d orbital is vacant. So electron can move. Electrons can excite it. Okay. Then what will happen, students? One electron from here, one electron from here, and one electron from here. They will excite it and go to the higher energy level. Go to the higher energy level. Now this one electrons and this one electron, they can excite it to the d orbital because it is filled. It is filled. Sorry, it is vacant. It is vacant. Okay. Then student, you can see how many valence electrons may be there. Now you can see there are unpaired electrons 6, means it can form maximum 6 bond. It can form maximum 6 bond. So it can overlap. These all can overlap. So 1s, 1, 2, 3, 3p and 1, 2, 2d. So students, hybridization will be sp3, sp3d2. Hybridization will be sp3d2. Okay. So students, what will be the geometry for this one? Now see. This one is octahedral geometry. This one is the octahedral. This one is the octahedral geometry, students. Okay. Here angles will be 90 degree. Angles will be 90 degree. Okay. So in this way you can draw the shape. Okay. I hope this is clear to you. Students, one more hybridization is also there. That is the sp3d2. That is the sp3d2 we have already done. That is sp3d3. For example, in case of IF7, here hybridization will be sp3d3. Students, we have discussed the hybridization in detailed way, but now we will see some tricks. How can we tell about the hybridizations of the given molecule? Okay, so now we will see some tricks about that. Students, simply we can tell about the hybridization of a molecule in simple way. Hybridization can be calculated by knowing the number of bonded atoms, by knowing the number of bonded atoms plus lone pairs, plus number of lone pairs. By knowing only these two things, we can calculate hybridization. Okay, students, you will see if this value of the number of bonded atom plus lone pair plus number of lone pair, if this value is 2, then hybridization will be sp. If this value is 3, then hybridization will be sp2. If this value is 4, then hybridization sp3. Okay. If this one value is 5, then hybridization sp3d. If this one value is 6, then hybridization sp3d2. And if this one is 7, then sp3d3. So in simple way, you can tell about the hybridization of a molecule. Like students, simply you have calculated hybridization for sp6. Now you have calculated. So we will tell the hybridization of SF6 by this simple trick now. By using this simple trick now. Now students, S. First of all, you will see the central element. Here central element is the sulfur. Okay. Then students, you will write configuration for this one. You will write configuration. So this is 286. 286, this is the configuration. Then students, you will see the valence electron. Here valence electrons are 6 only. Valence electrons are 6 only, means it can form maximum 6 bonds. It can form maximum 6 bonds. Okay. Then students, you can see F6 means it is forming bond with 6 chlorine. It is forming bond with 6F. Okay. So students, it is already forming all the bonds. Okay. It is consuming all the electrons in bond formation. So no lone pair will be there. No lone pair will be there. So students, hybridization will be number of bonded atoms. How many bonded atoms are here? 6. Plus all electrons are consuming in bond formation, so lone pair 0, lone pair 0. So bonded atom plus lone pair, this sum is equal to 6, and if it is 6, then hybridization will be sp3d2. Then hybridization will be sp3d2. So in this simple way you can tell students. Like students, you can take one more example. If I am talk about CH4, if I talk about NH3 and I talk about H2O, okay, then carbon, atomic number 6, configuration 2,4, means valence electron 4, means it can form maximum 4 bonds. It can form maximum 4 bonds. So bonded atoms are 4, already 4 bonded atoms are, okay. Then students, bonded atom 4, so lone pair is 0, H is equal to 4. So if this value is 4, then hybridization will be sp3. Now student, you can see in ammonia, central element is the nitrogen. So its atomic number 7. Then configuration 2,5 means valence electron 5. Means it can form maximum 5 bonds. But it is forming only 3 bonds. Because bonded atoms are 3 only. Here bonded atoms are 3. Okay, means 1 pair, 3 electrons are consuming only in bond formation. Okay, means 1 pair of electron, that is known as the lone pair. It is non-bonding. Means 1 lone pair here. So 3 plus lone pair are 1. So 3 plus 1, 4. And further hybridization will be the sp3. You can see one more example, H2O. Okay, H2O. In H2O, students, central atom is oxygen. Then atomic number 8. Valence electron 6. Means it can form maximum 6 bonds. But bonded atoms only 2. And bonded atoms are hydrogen, and you know very well hydrogen is univalent. It can form, one hydrogen can form only 1 bond. Means it is consuming only 2 electrons in bond formation. Means 4 electrons are unpaired. 4 electron unpaired mean 2 lone pair. So hybridization will be bonded atom are 2 plus lone pair 2. So 2 plus 2, 4. So hybridization will be sp3. Okay. So students, in simple way, either lone pairs are present or not, you will add only bonded atoms. Plus lone pairs. After that, you will see the value. If you are getting value 2, then hybridization will be sp. If 3, then it will be sp2. 4 it will be sp3. Okay, in this way you can tell about the hybridization, students. So if I talk about the geometry for the sp3, it will be the tetrahedral. We already discussed about that. It will be the tetrahedral. It will be the tetrahedral because but student, here CH4, NH3 and H2O all have different shape. All have different shape. Why? Due to presence of lone pairs. Due to presence of lone pairs. Okay, lone pairs, students, affect the they affect the shape, they affect the structure, but students, they do not include in the shape. Clear or not? Then students, ch4, no lone pair is there, no lone pair is there. So geometry is tetrahedral and shape is also tetrahedral here. But student, in case of ns3, what will happen? N, one lone pair. So this type of shape it is. This is pyramidal. This one is the pyramidal shape. But geometry is tetrahedral. Geometry for sp3 will be the tetrahedral. And for water, two lone pairs. Two lone pairs. Okay, so further shape change, and shape will be the bent shape. Shape will be the bent shape. But if I talk about geometry, then it will be tetrahedral. It will be the tetrahedral. Students, if lone pairs are there, then angles also change. Angle also get changed. Okay, due to Vesper theory, you know very well, due to Vesper theory, we already discussed about the Vesper theory. Vesper theory states that lone pair repulsion, lone pair repulsion greater than lone pair bond pair repulsion, greater than bond pair repulsion. कि जो हमारी लॉन पेयर रिपल्सन होती है वो मैक्सिमम रिपल्सन होती है, मैक्सिमम. ओके, लॉन पेयर रिपल्सन मैक्सिमम रिपल्सन होती है, एंड बॉन्ड पेयर रिपल्सन क्या होती है? मिनिमम. एंड स्टूडेंट्स, रिपल्सन इज इनवर्सली प्रोपोर्शनल टू द बॉन्ड एंगल. रिपल्सन इज इनवर्सली प्रोपोर्शनल टू द बॉन्ड एंगल. अगर रिपल्सन बढ़ेगी तो बॉन्ड एंगल क्या होगा? डिक्रीज होगा. बॉन्ड एंगल क्या होगा? डिक्रीज होगा. ओके स्टूडेंट्स, यहाँ पर मेरे हैंड्स ने 180 का एंगल बनाया है, यहाँ 180 का एंगल बनाया है. बट अगर कोई ऊपर से यहाँ पर प्रेशर डालेगा, अगर ऊपर से यहाँ कोई प्रेशर डालेगा तो मेरे हैंड्स क्या होंगे? यहाँ से बेंड होंगे, एंड बेंड होंगे तो ये एंगल क्या होगा? डिक्रीज होगा. अगर बेंड होंगे तो एंगल क्या होगा? डिक्रीज होगा. ओके, सो लॉन पेयर रिपल्सन इज द मैक्सिमम एंड बॉन्ड पेयर रिपल्सन इज द मिनिमम. एंड स्टूडेंट, इफ रिपल्सन इंक्रीजेस देन बॉन्ड एंगल डिक्रीजेस. सो स्टूडेंट्स, व्हाट विल be the angle in CH4? In CH4, no lone pair, so they have regular geometry, they show the regular geometry. So here angle will be same, 109 degree 28 minute, 109 degree 28 minute. But in NH3, in ammonia, this angle will be around 107 degree. Angle decreases. Why it is decreasing? Because in case of CH4, because in case of the CH4, only bond pair repulsion is here, no lone pair. So bond pair repulsion is here, and this repulsion is minimum. But students, in ammonia, presence of one lone pair, due to presence of one lone pair, so here lone pair bond pair repulsion take place, lone pair bond pair repulsion take place, and this repulsion is greater as compared to the bond pair repulsion. Because repulsion increases, so bond angle decreases, so bond angle decreases. And student, further, if I talk about the water, here angle around 104 degree, around 104 degree approximate. Okay students, so why it is Why it is? Because in water there are two lone pairs. There are two lone pairs, and lone pair repulsion is maximum. Lone pair repulsion is maximum. If repulsion will increase, then angle will decrease. Then angle will decrease. Okay, students. So in this way, in simple way, you can calculate hybridization also. We can calculate for some more compound. Like students, if XEF2 given, XEF2 given, then tell about the hybridization for this one. Tell about hybridization for this one. How can you tell? Simply student, first of all you will identify the central element. Here central element is xenon. Now student, you don't know about the atomic number of xenon, but you know xenon is the element of group number 18. Xenon is the element of the group number 18. Group number 18 means here valence electron will be 8. Here valence electron will be 8. So valence electrons are 8. Valence electrons are 8. Means it can form maximum 8 bonds. It can form maximum 8 bonds. But student, it is forming only 2 bonds, because here bonded atoms are 2. Bonded atoms are 2. Okay. Plus, so 2 electrons are consuming in bond formation. So 6 electrons are unpaired. 6 electrons means 3 lone pair. 6 electrons mean 3 lone pair. So students, here lone pair are the 3. So 2 plus 3, 5. And 4, 5. This hybridization will be sp3d. sp3d. Okay. In this way you can calculate, students. But students, if you are having XeO2F2, then what will be the hybridization? So further, we know very well in xenon there are valence electrons 8 valence electrons. There are 8 valence electrons. Okay. Then students, it can form maximum 8 bonds. Okay. You will compare with this one. Here 2 oxygen, try to understand 2 oxygen, and you know very well 1 oxygen has tendency to form 2 bonds. Okay, oxygen is bivalent. 1 oxygen can form 2 bonds. So 2 oxygen can form 4 bonds. Okay, students. So 4 bonds made by this oxygen, and 1 fluorine. Fluorine is univalent. Fluorine can form only 1 bond. So 2 fluorines can form 2 bonds. So 2 bonds fluorines are forming. Okay. So total, students, 6 electrons are consuming in bond formation. 6 electrons are consuming in bond formation. 6 electrons are consuming in bond formation means, and total valence electrons are 8, means 1 lone pair is here. These 2 electrons which are not taking part in bond formation, so these are the lone pairs. So 1 lone pair is here. Lone pair 1. Now further we will calculate hybridization is bonded atoms plus lone pair. Bonded atoms plus lone pair. So bonded atoms are 2 plus 2, 4. 2 plus 2, 4. Okay, students. Plus lone pair is 1. So 4 plus 1, 5. 4 plus 1, 5. And 4, 5, hybridization will be sp3. Hybridization will be sp3. So in this simple way, you can tell about the hybridization. Okay, students, I hope this concept is clear to you. So students, we discussed about the hybridization. What is the hybridization? Hybridization क्या होती है? Intermixing of the atomic orbital. Okay, intermixing of atomic orbital, and after redistribution they give the hybrid orbitals which have equivalent energy. Okay, after that, students, we discussed about some features. Features were हाउ मैनी एटॉमिक ऑर्बिटल्स विल ओवरलैप विद ईच अदर, जितने एटॉमिक ऑर्बिटल्स आपस में ओवरलैप करेंगे उतने ही हाइब्रिड ऑर्बिटल्स हमें मिलेंगे, उतने ही हाइब्रिड ऑर्बिटल्स हमें ऑब्टेन होंगे। ओके स्टूडेंट्स, यहाँ पर जरूरी नहीं कि हमेशा हाफ फील्ड ऑर्बिटल ही पार्टिसिपेट करें, ये जरूरी नहीं कि हमेशा हाफ फील्ड ऑर्बिटल ही पार्टिसिपेट करें ओवरलैपिंग में, कई बार हमारे कंप्लीटली फील्ड भी कर लेते हैं। ओके स्टूडेंट्स, उसके बाद हमने पढ़ा हाइब्रिडाइजेशन में केवल उनमें होगी जहां बॉन्ड फॉर्मेशन होता है, ये कभी भी सिंगल एलिमेंट के लिए सिंपल जो हमारा जो सिंगल गैसियस एटम है उसके लिए हाइब्रिडाइजेशन हम नहीं बता सकते। देन स्टूडेंट्स, हाइब्रिडाइजेशन अगर किसी मॉलिक्यूल की हमें पता है तो हम उसकी शेप को प्रिडिक्ट कर सकते हैं। लाइक स्टूडेंट्स, मैंने आपको कहा कि भाई NH3 में हाइब्रिडाइजेशन sp3 है। ओके, अब हमने सारी हाइब्रिडाइजेशंस को डिटेल में पढ़ा है, तो मैंने कहा कि NH3 sp3 हाइब्रिडाइजेशन है, तो आपको कहीं ना कहीं आइडिया है कि इसकी जियोमेट्री टेट्राहेड्रल होगी, इसकी जियोमेट्री टेट्राहेड्रल होगी। आफ्टर दैट स्टूडेंट्स, आपको पता है कि एक लॉन पेयर भी है, एक लॉन पेयर भी है, तो मीन्स डिस्टॉर्टेड जियोमेट्री यहाँ होगी, और डिस्टॉर्शन के बाद क्या है, दैट इज द पिरामिडल, दैट इज द पिरामिडल। मीन्स अगर हमें किसी भी मॉलिक्यूल की हाइब्रिडाइजेशन का पता है तो उसकी शेप को भी हम प्रिडिक्ट कर सकते हैं। ओके स्टूडेंट्स, और यहाँ पर जो हाइब्रिड ऑर्बिटल्स होता है उसमें एक हमारा स्मॉलर लोब होता है और एक बिगर लोब होता है। जो बिगर लोब होगा दैट विल बी द पॉजिटिव एंड द स्मॉलर विल बी द नेगेटिव। सो स्टूडेंट्स, आफ्टर दैट वी डिस्कस्ड अबाउट द sp2 all and we discussed about the trick also. So I hope this topic is clear to you. Okay, so thank you, have a nice day.